Hey everybody, Daniel here from Basement Tech. I wanted to follow up the video from the other day where I talked a lot about hardware with this one where I provide more of a system overview and talk about the specific components that make up the functionality of the zimKnives monitoring system. As I said the other day, there are two major components: the Raspberry Pi based base unit and the ESP8266 based remote unit. If nothing else, just press pause and look at the diagram, and I think you'll kind of pick up what's going on here. But let me provide a little commentary for those maybe not familiar with some of the components. Over here on the Pi, and kind of at the center, is this a data broker called Mosquitto. The boxes in green are open source, freely downloadable packages for the Pi, and Mosquitto is no exception. A data broker provides two functions. One, it services clients which want to publish data, and then it makes that data available to clients which want to subscribe to data elements. Data is tagged with a topic, so the two things just have to synchronize on a naming convention, and you can provide a nice way to enable data flow around your system. Working my way up, and then I'll come back down, NodeRed allows me to visualize the data that the Mosquitto data broker knows about. NodeRed is configured using a graphical user interface. It is a green box, so it's freely available and downloadable, and it's really cool. It has built into it the graphics objects that you saw in the opening screen of the prior video, those graphs, those gauges, and then it serves up that visualization as web pages. It's essentially a web server. So these two together really kind of make up the heart of the system: Mosquitto for the data broker functionality and NodeRed for visualization. Now that we have those two components, we want some data, and that's where in terms of the physical environment, that's where the remote unit comes in. As I said, it's ESP8266 based. That little device programs like an Arduino using the Arduino IDE, and like most Arduino programs, you take advantage of libraries that are available, and this is no exception. The hardware again is provided by Adafruit. The top module here in yellow is a temperature and humidity module for which I use Adafruit's library. And similarly, this A to D converter, which reads the analog gas sensor, for that I use Adafruit's library as well. So then I've got data off of the hardware and into the program running on the ESP 8266 module, but I need to get it to that data broker. That's where a protocol called MQTT helps us out. This is I don't know if it's industry standard, but it's known well around the industry as a very efficient, low overhead way to get data from point A to point B. I think it was originally developed for NASA for satellites and deep space probes. The good news is there's a pub/sub library that talks MQTT over to the Mosquitto data broker, and then NodeRed reaches into the broker and subscribes to the temperature, humidity, and gas. One additional thing you note here is this NTP client, that's Network Time Protocol. So I send along with the data a time, and this time is synchronized via the Wi-Fi out to the internet, to the National Institutes of Standard and Technology's time standards. So I send along with my temperature, humidity, and gas the current time. I display that on the NodeRed UI, and I can just kind of compare that visually to my system time and know that my data values are up to date. Again, MQTT over Wi-Fi through my local router and back over to Mosquitto and visualized by NodeRed, served up as a web page that I can view anywhere that's network accessible. Through a little bit of port forwarding magic on my router, I can see that anywhere in the known universe. So that's pretty cool. There are a couple more boxes I haven't talked about. I do have a few sensors and inputs and outputs hosted locally on the Pi. I pointed at those. They were all the ones mounted to that piece of wood. So for example, the motion sensor comes in through one of Raspberry Pi's GPIO pins. I read that using a custom written, very small, compact Python program, which publishes that data to Mosquitto. So again, you see that everything ends up at this Mosquitto data broker, and that provides a very consistent interface for managing data. Again, luckily, there are libraries available for MQTT, and there's a library for GPIO that I just include in my my Python code that allows me easy access to the pins and a very easy way to publish it via a standard protocol. Now note, in the case of temperature and humidity, my sensors were remote and I was sending MQTT over Wi-Fi. In this case, and it's to be highlighted, that your data source doesn't have to be remote, it can be local. So to the software, it looks the same, the interface looks the same. I just specify an IP address where the Mosquitto data broker exists, and I can access that locally just like I do remotely. I could even access that across the internet if I choose to. I don't choose to in this case because I wanted the system to be kind of autonomously providing the look at my data via a web interface. But you could do that. You could lay out these components differently if you choose to. Let's see, what else? Oh, for outputs, I'm still debating this, but I think I'm going to do use NodeRed, Mosquitto, and this local Python code in a chain in the direction going in the opposite direction, where on the NodeRed interface I can push a button. It sends an MQTT message to Mosquitto onto the Python code out to the solid state relay, which would light lights. I think those are all the components, and I'm going to do that chain in a couple different ways for lights and maybe some other MOSFET driven outputs, but the idea is the same in all of those cases. Finally, just to make sure I talk about all the boxes, there's a separate program that runs kind of independently of all of the rest of the system, a separate package called Motion, which allows me to plug a USB camera into the base unit and access that video remotely. So I think you can see in this format, it's there's not a lot of rocket science in this data flow, and I'm taking crazy advantage of all of the packages and interfaces and protocols that are available publicly in open source. So I need to say thanks to all of those developers. I'm really bad about keeping track of everybody whose code I've looked at on the web, but I want to use this opportunity to say thanks, because a lot of your discoveries have made their way into my simple monitoring system. I hope this video helps you understand kind of what's going on in a little better way. Again, another good opportunity to press pause and just stare at the diagram and think about how the data flows. But I think this topology is valuable in many applications. Alright, there you have it. I hope that brings clarity and not more confusion. As always, if you like this video, press the like button. If you really like it, subscribe to the channel. I wouldn't mind that. We're up to nearly 50 subscribers. That's pretty exciting. And finally, please don't hesitate to post your questions and suggestions, comments in the comment fields at the bottom, and I'll be sure to answer or at least engage you in discussion about these topics and any other topics. Future videos are going to be diving even more into the detail, the code, actually looking at the code, seeing how these pieces fit together. My next video is going to be on I/O in general. How do you know what things you can connect to what things physically? For example, I want to control 120 volt light. How do I do that with a Raspberry Pi, and how do I decide how to make those connections? So I'm going to go over some of those things in the next video, and I hope that will be useful to you. Thanks, and talk to you next time.